Well, dear friends, now I'm again solving many questions. This question has been asked in class 12 exam in 2018. What is that? It is an equiconvex lens or index 1.5 equiconvex, double convex, placed on a plane mirror having some liquid between lens and liquid. When we take a needle along the axis, parallax is removed at distance x from the mirror. When liquid is removed, then parallax gets removed at distance y. Y distance पर parallax remove होगा. Only the lens is placed on plane mirror. Obtain value of n in terms of x and y. So this is this question in NCERT is given in other way. X and y value are known to, are given there. I will tell later on. Yeah. So you are asked here to find the value of index of liquid. This liquid का index निकालना है in terms of x and y. I have told you while telling if we have this convex lens here and there is parallel plane mirror. If here object is placed and we get image here same size, then what is this point? And where this is plane mirror. How it is possible? If light after starting from this point become parallel to principal axis, then they are incident normally and get reflected back on the same path, and then image will be formed here, same size. Now it does not matter whether mirror is here or touching it. Then this distance is focal length. If object placed at focus, when plane mirror and lens, convex lens are like this. So, from figure 2, in figure 2, y is the focal length of lens of equiconvex lens. Equiconvex lens. Let R1 is equal to R and R2 is equal to minus R, because it is equiconvex from lens maker formula. That is 1 upon f equal to n minus 1 into 1 upon R1. So 1 upon y is equal to 1.5 minus 1 into 1 upon r minus 1 upon minus r. 1 upon y is equal to 0.5 into 2 by r. यानी कि y is equal to r. यानी कि radial curvature of this lens equal to focal length y. Now what is this x here? So here we have got के radial curvature of this lens ry, focal length of this lens y. Now in figure 1, x is the focal length of combination of glass lens and liquid lens. There is a big number of problems in ray optics, but we should not avoid, we should try them. So, if small f be the focal length of liquid lens, this is the liquid lens here. It is in shape, it is called plano-concave. Then from equation 1 upon from combination of lens, the equation 1 upon f is equal to 1 upon f1 plus 1 upon f2. So 1 upon f here is 1 by x is equal to that of lens 1 upon y or plus 1 upon f or 1 upon x minus 1 upon y is equal to 1 by f. But again 1 by f, you know, equal to n minus 1 into 1 upon r1 minus 1 upon r2. So using this for liquid lens, this is r1, this is r2, and this r1 is equal to minus y, r2 infinity. So here we will use this. So here is LCM xy, y minus x is equal to 1 upon f and minus 1 into 1 upon minus y minus 1 upon infinity. Because radius curvature of this double convex lens have magnitude equal to focal length and is the index of the liquid. Y minus x upon xy is equal to this minus here and minus 1 upon y. This y get cancelled. This minus sign can change this here. Is equal to n minus 1. So n is equal to x minus y upon x plus 1 is equal to x minus y plus x, यानी कि 2x minus y upon x. So value of n here comes out to be n equal to 2x minus y upon x. We can obtain the value of x in our NCERT book. This is the last question of NCERT book in ray optics. There you are given this distance 45 centimeter. This is 30 centimeter and 1.5. So we are asked to find the index of this. So we don't need to derive this. We can directly do कि अगर ये 45 है तो 45 if x equal to 45 centimeter, तो 45 centimeter focal length of combined lens and f for this lens is 30. Then from combination of lens, this x 45, मान लो ये f इसकी पूरे की होगी f, ये f1 लेंस की होगी, लिक्विड की f2 मान ले तो f2 निकाल लेंगे, and using this equation, which one? 1 upon f equal to n minus 1 into 1 upon we can find again. तो ये अच्छा क्वेश्चन है, इसको आप कर सकते हैं अपने आप. Please find it. So this was one question here. Now there is another question here. Here is a convex lens. The focal length of this lens is 10 centimeter. 10 centimeter. An object on the left side is placed at 20 centimeter. Suppose it's a point object. On this side of this lens is placed a concave mirror. Concave mirror. The distance between mirror and lens is 30 centimeter. 30 centimeter. Focal length of mirror again 5 centimeter. दिख रहा नहीं? चलो focal length of mirror 5 centimeter. Question is like this. I am reading here. An object is placed at a distance of 20 centimeter to the left of convex lens of focal length 10 centimeter. A concave mirror of focal length 5 centimeter is placed at distance of 30 centimeter to the right of lens. Find the position and nature of the final image. Draw the ray diagram. बुनेगा तो ray diagram. So it is very clear here. This question has been asked again in board exam. नहीं तो यहाँ लिखा है, देखा था मैंने. तो कैसे करेंगे भाई? This is object at 20 cm, focal length 10. From lens equation 1 upon v minus 1 upon u equal to 1 upon f. 1 upon v minus 1 upon minus 20. 1 by 10. 1 upon v ये plus 1 by 10 minus 1 by 20. तो 20 LCM 2 minus 1. तो v इक्वल टू प्लस 20, यानी कि ये 30 है तो यहाँ पर 20 सेंटीमीटर दूर, तो ये बच गया आपका 10. द इमेज फॉर्म्ड बाय लेंस 20% विजिबल था. ऑब्जेक्ट प्लेस एट 2f. व्हेन ऑब्जेक्ट प्लेस एट 2f, रियल इमेज ऑफ सेम साइज फॉर्म्ड एट 2f 20 सेंटीमीटर. तो दिस इज चेक. Since focal length of concave mirror is 5 centimeter, so its radius of curvature, radius of curvature is equal to 10 centimeter. Therefore, image formed by lens is at center of curvature of concave mirror. If it is center of curvature and this ray fall here on mirror, it is falling normally. Radius perpendicular tangent, and when ray fall normally, that is reflected back on the same path. So it means the finally image will be at O. Any ray of light passing through center of curvature of mirror fall normally on the mirror. Hence, the ray shown in figure reflected back and final image will be at O. Hence, ray of light starting from O will be reflected back and hence image is at O. Final image is at O. So you have to understand. So simply you can show this ray, second ray like this, reflected back. So this was one question here. In competitive exam there comes very good questions. I'll be taking in next video some questions from competitive and test examination. Thank you.